Hello and welcome back. Alright, this is going to be our design video and explanation of the rules for Tic-Tac-Toe. I do want to preface this with just kind of an explanation of what our goal for our design videos are for when we sit down to design applications. I'm going to be designing the applications pretty much on the fly. I'm not going to spend too much time before the design lessons, making sure that we get the design right the first time through, and just kind of walking through a pre-scripted design session that I've already done. And I'm doing this for a couple reasons. The first, I really don't want to get or impress upon you this notion that you get a design right the first time through, or that in order to start coding the solutions to your problem, that you need to have a fully fleshed out design. And I went back and forth on whether or not to just show you a finalized design, but I figured it's really going to be a better experience for you to kind of walk through the design process with me, see the mistakes that I make, and I'll be vulnerable to my errors here for you guys, so you can see when I do something really stupid, and maybe you'll notice and just have to bear with it. But I really want to impress upon you that design is really kind of a loose flowing thing, and you don't have to have the perfect design in order to move on to the next stage. In the next piece, I just really just want to show you how I go about coming up with designs for different applications or different solutions for different problems. And so hopefully you'll be able to learn both from the mistakes that you see me make, and then how I adapt to those mistakes and go through and correct them. Hopefully you'll be able to learn from that, and then also learn how I design things and see if that actually works for you. Okay, with that, let's go ahead and talk about Tic-Tac-Toe. Tic-Tac-Toe. Okay, so this is the first game we're going to be making. We're actually going to start out with a console-based version of Tic-Tac-Toe, implement our base engine, we'll call it, and then move into the graphics front end. But let's explain Tic-Tac-Toe first. So Tic-Tac-Toe is a game where you have a 3x3 grid. So you have a grid that looks something like this. And the object of the game is to get 3 of your letters, or 3 of your pieces, to line up in a row. So you can either go horizontally, would be this way. You can do vertical, this way, or diagonals in any direction. And there are 2 pieces. There's an X piece and an O piece. And the X is going to be player 1, and the O is player 2. And to play the game, you alternate turns. So X goes, then O goes, back and forth, until you either have a winner of the game, or there are no places left to go on the board, and that's a tie game if there is no winner. So, okay. So we know, let's try what we know. So when we're coming up with a design for the game, we know three quick things right here. We know that we have a board, right? And we know that we have two items that represent a player, and we can call these pieces if we want to. All right, so now when we think about all the data structures that we've learned and how to create data structures, we have a pretty good idea how we could create a board. We could do a 2-dimensional array, or we could do a single array and just have 9 slots, and this could be 0, 1, 2, 3, 4, 5, 6, 7, and 8. Or we could also create an actual board type, and then we can say we could do things like row, and then pass in some value. Let's say row 2, and we could say like column 1, for example, and that would get you some information. So I think I'm actually going to go ahead and go the board route. I'm doing that because arrays, we could do an array, and it would be kind of an optimization-ish type thing, but we're not really constrained by memory. and I want to make my program easily readable and easy to program against. So I'm going to go ahead and create a board class. Okay, so let's put a list over here of classes that I'm going to be making. All right, so we're going to have a board class. Let's see here. What else are we going to have? We're going to have a player 1 and a player 2. Okay, so we know we're probably going to have a player class then. Now, if you remember back from the video, I told you we were going to be doing some AI. So that means there are two potential types of players, right? There's a real person, and there is a computer player. So let's go ahead and say that there's a player is going to have two possibilities, right? We could have human, or we could have computer. And so we might do an inheritance thing going on there. Or we might do something else. I'm not quite sure yet, but this is kind of what I'm thinking about. We have the board represented. We have our players represented. The only thing we're missing representation for really is the pieces themselves. So we're going to need some sort of piece class or piece structure or enum or something like that. Okay, and so this is going to have our X and O options. And with that, I think that's kind of what I want to do with this game. Let's go ahead and sketch out what we think this board class is going to look like. So let's create a nice little layer for us here. Okay, so we're going to have a board. And this board, like we know, let's draw it over here, has 9 positions. We know a couple things that we need to do. One, we need to validate whether or not the board is in a winning state. So we need some sort of check-win algorithm. So we're going to create a function on here, and it's going to give us back the player that won. Okay, so maybe it sends us back a player pointer, and maybe we'll say check winner. Check for winner. Okay. So the idea of this is going to check all the positions and determine if there actually is a winner on the board. It's going to give us back the player if there is one. Maybe we might has is winner, and it gives back a reference to the player that's working, or we can just do this and return null if there is no winner. So we're going to need something like that. We're going to need access to the positions on the board themselves. So how are we going to set X to this position right here if player 1 wants to move there? And that position is going to be 1, 1. Remember, it's well, we're going to zero based. We're just going to treat everything as zero based when we're dealing with design work here for computer programs. So we start at 0, so that's 1, 1 on the board. How are we going to set that? We could do set position, pass in the X, Y, and then pass in the player type. That might work. That actually sounds kind of good. So we're going to have a void set position. Oops. And it's going to take an X and a Y, and it's going to have the player. Okay. So there we go. We got. So I'm obviously not really specifying types here. I'm just kind of loosely defining what our function APIs are going to look like. So we got set position. So if player, maybe this is a player pointer or something. So if we want to clear the board, we can either pass in null here and it erases that position. But we're also going to need a clear board. So let's go ahead and create a clear function. Wow, I hope this isn't too messy for you guys. Let me rewrite that. That's pretty bad. Okay, clear. That's a little bit better. All right, so now we have our board. It's check for winner, set our position, and we have clear our board. You know, off the top of my head, that's kind of what I'm thinking that we're gonna need. Um, we also might want the board to be able to draw itself. Um, so let's go ahead and create a render function. Okay. You know, I think that's pretty good. I think that's what we want for board. I'm pretty happy with what that is. Um, okay. So how would we define our player class? Okay, we got our board class up here. We got our player class now. What does a player do? Um, a player has it has the ability to choose a location to move. So maybe we have a function called like wait for player move or wait for move or get player move or something like that. So let's call it mm, determine move. I like that better. Determine move. And you know, this could be a virtual, so our human player maybe is by default, is what the player class is. He's really just a human. And we can override that determine move. Um, for the player, we could say, hey, you know what, tell me where you want to move. Computer, we could say, hey, you know, figure out what you want to do based on some heuristics or some algorithm that we create to generate the location in which we want to move to. So player can determine move. He can make his move. Um, you know, I guess a player could give up. Tic-Tac-Toe is not that stressful of a game, so I don't think we need to add that functionality in there. Um, you know, I think that's pretty much what we need. We also want to render for the player as well. I think we want that. Hmm. So what I'm thinking right here is that do I want my player to render that X, or do I want my board to be in charge of rendering um, that, and the player is really just assigned a piece type. And I think I actually like that better. So a player is going to have a property. So we'll have set get piece type, I guess. Um, so let's just write that down. We'll have a set slash get piece type. You know, we'll pass in p as the piece. That's obviously not anywhere near close to valid C++ syntax, but the idea is there. So, you know, I need this getter setter for my piece type when I create my player, and you know, maybe that's just in my constructor, um, and then I just have a get piece type, and I don't provide a set. I think I'm actually kind of liking that better because a player always has to be associated with some piece type. He either needs to be associated with X or O. So let's go ahead and just show that we're going to have a player constructor, and it's going to take in the piece type. And I'm going to go ahead and delete that set. I'm not going to allow you to change your piece. Okay. Um, you know, I think that looks pretty good. I think that's what I like for player. He has to figure out where he wants to move. He has a piece type associated with him, and he has a player constructor that creates a new player. Yeah, I think I like that. So let's go back to our original layout here. We have piece. You know, I think that's going to be an enum. We can write it out if you want to. That's fine. Piece type, and we'll have a X and O be those values, and this is just going to be an enum. I think we covered enums. Uh, if we haven't, enum's just a way to define custom symbols, essentially. So that I'll be able to say piece type X, piece type O, and then use those as constants, essentially. So we got piece type, we got board, we got player. Let's look back over at our original whiteboard. We got piece, player, board. Yeah. So the other piece is that the other piece, The other thing I didn't talk about is, I mentioned that there's going to be some sort of game engine. So let's go ahead and create a new layer for that one. And let's talk about what that game engine is going to be. Okay, so typically when you're in a game, what happens? You start up a game, and the game kind of maybe goes through some loading the screens, and eventually you get to a main menu where it kind of sits there and it waits for some sort of prompt. So maybe it says press start to continue, or you pick a game mode you want to be in. Like maybe if it's Madden, there's like that menu right on the left side of the screen that you go through and say, oh, play now, or do a franchise or something like that. Well, what's going on is that it's in this loop, right? It's just kind of waiting for you to do something. And so that basic concept is what's known as a game loop. So let's see here. We have this thing called a game loop. And the basics of a game loop is really it's kind of uh, get user input, uh, update the game based on that input, and then draw the game, and then jump back up. That's basic. That's essentially what a game loop is. That's a really simplified version. But we're going to want some sort of game engine because we're going to make this a graphical game eventually, and so we're going to want to just go ahead and set up our text-based game the exact same way so that we can convert our text-based game into an OpenGL graphics game with relative ease. So what we're going to think about for our game engine is, okay, we have that main function that we have, right? Every program has that main function that was going to be our entry point into our application. But we want our game engine to be kind of abstracted out. We don't want to just have our main function like coded our game loop. So what we want to do is basically create a game object, a game engine object, and then call a method on it to start our game. And we're going to call that method run. So essentially, run is just going to be our game loop. It's going to wait for user input, well, depending on the player, right? It's gonna get the move. It's going to update our game engine, and then going to render. Tic-Tac-Toe is not a graphically intense game, so we don't actually need to continue to loop here in this process. We can just wait until you tell me where you want me to place your piece at, and then I can update the game, and then I can render, and then I can go back up here. But let's say maybe we wanted to have some animation in the background going on, maybe a spinning ball or something behind our game board. Then you definitely want to not block. Blocking is kind of the term you use to mean that you're going to stop executing code. So maybe you'd actually want to keep doing this because with that update, the update getting called with the time that it's getting called at would allow us to animate. So yeah. So basically that run is going to do our game loop, and then we'll figure out how we want to implement that stuff when we get down there. But essentially the way I'm thinking about it right now is just we're going to wait for the user input, call update after we get it, and then render. Same thing with our OpenGL version, because there's really no point in redrawing the screen 60 frames per second or however often we want to if nothing's really happening. Okay, so our game engine has run. That's pretty much all the public API I want on top of the game engine. It's just going to do run. It's going to execute that game engine loop and call into our basic classes. So with that, yeah, that's going to go ahead and wrap up this kind of free-flowing design of Tic-Tac-Toe, and we'll jump into the coding of it in our next video. Thanks.